In this presentation, we're going to talk about the basic components of a 3D object. 3D objects are made up of points, edges, and polygons. And if we look over at the left side of the screen, we have the different component parts here represented by these cubes that highlight points, edges, and polygons. And as I roll my mouse over, you can see that I'm getting a little tooltip that pops up. Now, in order to start to modify a parametric primitive, we need to convert it to a polygon object. And I'm just going to get started by creating a primitive object, a cone. I'm going to move that cone up into a place where I can see this a little bit more clearly. I'm going to tap the S key so I can zoom in a bit, and I'll just kind of reframe this. Now this object, if I look over in the Attributes Manager and I focus on the Object tab, it has a top radius and a bottom radius, and of course we can change those values and key in whatever we want, numerically change those. It also has a height segments and a rotation segments. Now the segments are describing the amount of information that are in this piece of geometry, and currently I'm not seeing the component parts of this object, and I can change that by going to Display, and currently I'm looking at Gouraud shading. And what I want to do is change this to Gouraud lines. Now, these shading levels are just kind of on this continuum of highest detail to lowest detail, but they each include a different line view. So if I turn on Gouraud shading lines, you can see that it renders the actual lines of the geometry. Now, with this cone selected, if I go into the height segments, as I reduce those segments, you can see that the height geometry becomes reduced. Now, if I set that back to 8 height segments, the segments of this object, the height segments of this object, are these different strata of polygons. So I have 1, 2, 3, 4, 5, 6, 7, 8, all the way up. Now, if I change that and I reduce that down to something like 4, you can see now that I have kind of different strata in here. I now have 4 height segments as it reaches the top of this cone object. The rotational segments are the number of polygons or segments that are around the cone. So if I reduce the number of rotational segments, you can see that this object becomes simplified. We can kind of think of segments as the resolution of our object. The higher, the more segments that we have, the more opportunities or the more information that we have to modify an object, but also the more stuff that we have to manage. So we want to strike this balance of, we want an object with just enough geometry in it so that we can describe the shape and the form that we need without having a tremendous amount of content that we can that we have to manage. Now we can always add geometry as needed. We can also remove geometry, but it's best to kind of find that right place of how much geometry do I need in an object in order to describe the thing that I'm trying to make. And also consider that as we add segmentation to an object, we're increasing effectively the resolution of that object. And the more taxing it is on our system resources ultimately to render, to move, to modify this object. Not to mention it's taxing on us to keep track of all these different segments. So I'm going to set this back to height segmentation of, let's say, 6. The rotational segmentation, I'm going to take this down, probably to like 16. Well, let's see. Let's do 24 for now. We'll keep that fairly high. So I've reduced this object a little bit in terms of the amount of geometry that's in it. Now what I want to do is I want to modify its component parts. And its component parts, let's zoom in here. One of these rectangles is considered a polygon. It's the 3D surface of the object. Surrounding the polygon is the edge, so it's the line that helps describe one side of the polygon, and where those edges intersect are points. So we have points, edges, and polygons, and we can actually modify our object based on those component parts, but before we do, we need to convert this from a parametric object to a polygon object. And the way that we do that is very simple. We select the object we want to convert, and we go over here to the top of the left side of the toolbar here, and that first tool says Make Editable. Now, we can click on this button, and it converted our cone object, and a couple of important things happen. The first visual cue that we get is in the Object Manager. Our cone its icon switched from a parametric cone icon to a polygon object. And just to compare this, I'll introduce a new cone into the scene, and I'll kind of move this up and over. They look the same, so those are two different kinds of objects. I'll select my polygon cone. That was the object we just converted, made it editable. And you can see that the new cone that we created has a cone icon, a little bit different than the triangle with the points underneath it. Now that's important because a polygon object, we cannot modify its attributes anymore. I mean, there's a few things that we can modify its position in space and some of its basic coordinate and Phong components. But as I select this parametric cone, you'll notice that when I go down to the object manager, there's more tabs here. And at this point, we've been basically looking at the object tab when we modify our parametric primitive. That's the place where it contains all the information, you know, the size and the segmentation of the object. But when I select the polygon object, we don't have the ability to influence this based on numbers anymore. We have to describe and modify this based on its component parts. I'll go back to my parametric primitive just for 1 second and just point out that we have 6 tabs of information in the attributes manager. We've been primarily looking at the object tab at this point, but we can also look, you know, shuffle through these tabs, and at this point we should start familiarizing ourselves with some of the other options that we see in different places in Cinema 4D. I'll go back to the object tab. So this is a surefire way to tell that this is a parametric object still, because I can still modify its segments. I'll delete that object and we'll focus on the cone object that we've created. Now, there's going to be no substitute for experience when it comes to trying to determine how much segmentation you want in a model to describe it, and at what point you want to convert it. But you'll arrive at that pretty quickly. Now, if I want to turn this cone into a caret, I probably wanted to get the shape a little bit closer to what I originally wanted, because what I'm going to do is I'm going to modify this object. Because I converted it, I can go into its component parts now with these tools over here, and I can modify its points. And as I click on points, if I roll my mouse over here, you can see that I can highlight just by rolling over the intersection of the edges, which are the points, and I'll just click on one point. I get these 3 axes, the move axes, and you can see that I can move this point just like I would an object. It's attached to that geometry, and the surface changes to reflect that new position of the point. I'll go over to the edge mode, and now as I roll around this object, you can see that I'm highlighting the different edges. I'll just click on that and pull one of those edges out. So you can see I can modify that geometry. Now, just beneath edge mode is polygon mode, and that will allow me to click on these surfaces, so these polygon surfaces, and just kind of move those around. So you can see that I can start to modify and deform the shape. Now, this is not the shape that I wanted to create. But I just wanted a place to experiment with the different components of the 3D object. And remember, you cannot access these components until you convert this to a polygon object. Now, it's important that once you start modifying the component parts, and once you model things and you're done with your first kind of sculpting of it, and if you want to move the object or kind of get back into object mode so we're not influencing these components, this button just underneath the button that we clicked on to convert it to a polygon object, just underneath that, this is the model mode. So I want to go back into model or object mode. I want to go back to the model, and that allows us to move this as an entire object. Okay, and then if I want to modify the polygons or the points of the edges, I can just jump back in and select that content. Now, now that I've sufficiently destroyed this cone, I'm just going to delete it and put a finer point on this idea of modeling an object. So I want to use a cone to create a caret nose. I'm using a cone because it's, you know, generally the same shape, at least the starting shape of a caret, but I want to add some kind of irregular or organic qualities to it. So I'm going to generate a cone, and I'm going to move it straight up on the y-axis. Okay, I'm not just driving it out in space somewhere. I'm going to move it up. I'm going to tap the S key and I'll just zoom out a little bit so I can see this a little bit more clearly. Now, if you're not seeing the segmentation of your object, remember to go up to Display and choose Girard shading, and as you create new files in Cinema 4D, you'll probably need to change that if you're not seeing the segmentation. So make sure, because this is a really important view. It tells us a lot of information about the object. Now, I want to make this like a carrot, so I'm just going to move that on top of the snowman. So I got a hat going here. I don't want a hat yet. I'll do that next. I want a carrot. So what I'm going to do is I'm going to reduce the bottom radius. I'll make it really small, and I'm just kind of eyeballing this here. I'm going to reduce the height, the overall length of the carrot, and I think that's pretty good for now. I'll zoom in just a bit. It might be a little big, might not be long enough. Who knows? I'm not sure that I have all this. I think I have too much segmentation, actually, but we'll talk about that when I get this into position. Now, I have two ways that I can rotate this object. The best way to kind of rotate an object in 3D space is by using the rotate tool. So by default, we're using the move tool, and unless you have a compelling reason, you should always go back to the move tool. It'll keep you from modifying, inadvertently creating stuff and rotating stuff. But I can move content in space with the move tool. Just to the right of that is the scale tool, which we'll visit here in a little bit. But to the right of that is the rotate tool, and I'll click on rotate. And you'll notice that to the right of rotate, as I click on these tools, the tool that's to the right of rotate is changing. And these are just the most recently used tools, okay? So as you click through tools, this will kind of build a dynamic list of the most recent tools you've used, and that can be a very useful thing. Now, I'm in rotate mode. I have the cone selected, and you can see that these axes bands that are showing up relate to the world space in 3D. So if I look down here in the bottom left-hand corner of this little widget, this little heads-up display, that tells me that Y is the up axis, and it's green. Z is the blue axis, and it's pointing back in space, and these correlate with these rotation bands. Now, they might look like they're not making sense, but the idea is that if I look at this object, just tap the S key to get in closer, I'll go back to move for just a second. The red axis, or the x-axis, is running through the object in this direction. Now if I go to rotate, that red axis is still represented here, but the rotate is around the x-axis. And the way that we can think about this when we want to rotate an object is if we think of this kind of like something we want to put on a skewer and rotate over a fire. So maybe we have a cube that we turn into a marshmallow. Let me just back up here and go to the move tool and lift this up. I'll select the cube and go down in the object attributes and just kind of bump down the size of the cube and move that a little bit closer, just so we can see this a little bit more clearly. If this is my marshmallow and I want to rotate it around the x-axis, we would want to rotate it around its x. So we can think of this axis as the skewer that runs through the object. So in other words, if I rotate this according to the blue axis or the z-axis, it'll rotate in kind of this this clockwise or counterclockwise fashion. Let's try that. I'm going to grab the rotation tool, and I'm just kind of orbiting around so I can see all three axes bands for this object. And as I roll over one of these bands, you can see it kind of highlights with a white yellow. And as I click and drag, it'll rotate around whichever axis the color is that I selected. So if I grab it according to the red axis, I can spin this object, grab it according to green. Now you can see that this object is kind of getting all flipped around, and when I go back to the move tool, you can see that its axes are pointing in, strange directions. It no longer registers with the world space. And that's okay, because each object has its own axis, has its own center point. And now I'm moving this object according to its own x-axis. Okay? I'm going to delete that cube. I'm going to go to the cone. And what I want to do is I'm being mindful of the front of my object. And what I want to do is I want to rotate this cone or this carrot so that it's sticking out of the front of the snowman. And the way that I'll do that is with the cone selected, I'll go to rotate, and I want to rotate around its red or its x-axis. And I'll just click and drag and rotate. Now as I rotate, I'm getting this little heads-up display here that's telling me that how many degrees I'm rotating it by. And if I look down here in the coordinates manager here, you can see that it's telling me the position, the size of the object, but also its rotation. And as I rotate that down, you can see that in this case, the P value is getting close to 90. Now, we can move objects according to X, Y, and Z, but when we rotate objects, we're talking about heading, pitch, and bank. And that's just, you can kind of think of kind of an airplane flying through space. The direction that it's pointing in is its heading. Its pitch is how far up or down it's pointing. And then its bank is how far it's leaning to the left or the right. And this assumes that you're kind of sitting in the position of a pilot or passenger in the airplane. But in this case, I'm just rotating the object. I'm changing its pitch. Okay, and you'll also notice that these values run in line with the axis that correspond to those values. So I want to rotate around the red axis, which happens to be X. Well, it looks like that's not the case, actually. So anyway, I'm modifying this according to pitch. Thinking of another application that lines those up in a different way. And I want to get that to 90 degrees. Now, I could just numerically type in a value into the rotation field and hit return or hit apply, and that'll drive that cone into the position that I want. Now, I'm going to zero out that value. Because it's tough to kind of tell what's the heading, pitch, and bank, just like X, Y, and Z, until you spend more time in Cinema 4D moving things around. But I know that I want to rotate this according to the red axis. And so what I'll do is I'll click and drag and start to rotate, and I want to restrict this. I want this to snap to 5 or 10 degree increments. And so as I'm clicking and dragging and rotating, I'm going to throw down the shift key. And now you can see that it's snapping to 10 degree increments. And I'll just snap that to 90 degrees. Alternatively, what I could do is I could figure out which axis I want to rotate this object on. I'll look down here in the coordinates manager in the rotation column, and I see that the pitch value is the value that changed. And so I'll just highlight that and type in 90. Okay, now I'll go back to the move tool. I'm going to move that down along Z, and I'll push it forward along Y. Now, I moved it down along Z and forward along Y because the original position of that cone, let me make a new cone and move that off to the side so that we can compare and contrast. When we make a cone, its Y direction is pointing towards the tip of the cone. Its orientation, if we look over here in the attributes manager, in the case of the cone, its orientation is plus Y. So as we rotate that position, I'll go back to my cone that I modified. When we rotate that, we're also rotating the X, Y, and Z of this object. So this no longer corresponds to the X, Y, Z of the world space, okay, which can be very helpful sometimes. Now, I could have chosen to change the orientation of this cone so that it's pointing along negative Z, okay, and then I could modify this object, and this object will act a little bit different than the cone that I rotated, because now this cone is positioned relative to the snowman the way that I want it, but it still has its Y-axis pointing up and its Z-axis registering to this 3D world. So that's the orientation of 3D objects. That can be fairly useful. But for this class, we're mainly just going to rotate things as needed. So I'm going to select my cone. Cone's a poor name. I'm going to call this carrot. And I'll tap the S key to zoom in. Now, this is still a parametric primitive object, so I cannot influence its points, edges, or polygons. I need to modify this object first, but I made a decision to change its bottom radius and its height, because if I wanted to try to do that after I converted it, I would have to go in and modify all the different points, edges, and polygons to scale this object down, which would be no fun. It would take a long time. So I'm getting this object as close as I can to the shape that I want. And then what I'll do is I'll make a decision about how much geometry I want in this object. And what I really want to do is I want to make this caret crooked. Right now it's more of a cone, but I want it to kind of zigzag along its profile. And what I'm going to do to describe that is I'm going to use its height segmentation, and I'm just going to move different areas or different edges to kind of cause this to zigzags. This is just kind of how I'm thinking about this object. I'll demonstrate in just a moment. But I might want to describe the zigzag as a pretty tight zigzag. I'll just reduce the height segmentation a little bit so that I have fewer rows of edges or fewer components that I need to influence. I'm not so concerned about the height segmentation because whether it's 6 or 8, that's pretty manageable. What I'm not real crazy about is the number of rotational segments around this object. So I'm going to reduce it from 36 to maybe half of 36. Now I could key in the value of 18, but I could also do some math in this field. If I go to the rotational segments and I just click my cursor, rather than using the arrow key or keying in a value, what I'm going to do is I'm going to type in /2 or divide by 2 and hit return, and you can see that that math then gets calculated directly in that field. Now I could multiply by, use the asterisk to multiply to 2 and get that back to its original, and I could just kind of eyeball it by all the ways that I've been able to modify this object. So I'll just take this down to say 18. So I'm reducing the number of segments. It's still more rotational segments than I actually need, but we'll manage this pretty effectively. So for now, I've been able to rotate my cone, change its size, get it into the position that I want. I've made some decisions about how much information this model contains, and now I'm going to get to the task of modifying this object. I'll do that in the next presentation. We'll convert this object to a polygon object, and then we'll modify some of its components, but we'll do that in the next presentation.